1. Let's go. In this one, this is, I guess, part number 2 of the introduction to the creation of kind of going in the direction of perfect squares for quadratics. And the goal will be that if we are given what A is here, and then if we're given what B is here, we will try to find a C such that we get basically a perfect square from the expression. Now in part 1, I have assumed that A was equal to 1, and in that case, so we would have this particular expression where A was equal to 1. If you want to watch, and I do encourage you to watch that video first, I'm going to put up a link up above. In this video, I'm going to make the assumption that A is not equal to 1. That's what I'm going to do. Now, just as a short refresher, for A is equal to 1, if that's the case, then we can always find the C, and this particular C was basically equal to whatever your B was. So this was B divided by 2, and we would square the entire thing. For example, so here's 2 examples right here just to refresh you. If I wanted to find what this question mark is, which is basically the C, and notice that A is equal to 1, or if I wanted to find the second question mark here, what I would do is I would simply take my B, so divided by 2, which is going to be 6, and then square it, which would have been 36 in this case. Now, once I have that, of course, I can find the perfect square and I can factor it out. So I can factor that whole thing out. It's just going to be x plus 6 squared, and that's my perfect square right there. For the second example, right here, and I purposely put, notice that here I have a positive, and then here I have a negative. The positive, all it does is when you have the factored form, so the positive appears right there. For that second example, as you can see there, so it's 20. So what I'm going to do is I'm going to take 20, I'm going to divide it by 2, which is going to give me 10, and then 10 squared is 100. And that is my C for this example. And again, if I wanted to make this in factored form, so this entire thing, now that this is 100, this would simply be x minus 10 squared, and the minus is coming exactly from right here. That's the sign. And this is what we had with A was equal to 1. So it wasn't very difficult to find our C and basically create a quadratic which is in perfect square format. Now, what happens if A is not equal to 1? So what if we start running into examples like this, where your A is not equal to 1? What can we do? Well, it turns out it's actually not that difficult. Now, it's just one small little leap that we have to make. And then after making that leap, then we can find our quadratics, kind of expand things out, and then find exactly what this C should be right here in order to make these perfect squares as well. So let me show you how to approach that. First off, I'm going to just take right here, so I'm making the assumption that I have ax squared plus bx. Now I know what this a is and I know what this b is. And I do not know, and I'm going to try to find the c, so such that I basically create a perfect square. Now the one first step when you're approaching these, and it's the easiest thing to do, is just use factoring. Meaning, I'm going to transition from here, since my a is not equal to 1, I'm going to factor out the a entirely. And if I factor that a out, I'm going to get a, and then here, so this is going to be x squared, plus, this is b, over a, because I'm factoring out the a from every single term. That's what I have there. And then plus, and this is going to be c over a. Again, the idea is, now if I brought that a back in, then I would just get the line above, right? So if I would just distribute this across, I would get exactly what I have right here. So that's the first thing. It's kind of a little bit of a trick, sometimes students call it, but all I'm doing is factoring. Now to clean this up, because I don't like looking at this b over a and then the c over a, because remember, our goal is ultimately to be able to find the c, because a and b are given, so they're just basic numbers. And if I want to clean this up, then what I'm going to do is I'm going to transition this, and I'm going to put it in a form which basically looks like the a is equal to 1. So I'm going to forget this a in the front for the moment. Just going to say I'm going to worry about that at the end. And if I now transition this, so I'm going to call this b over a, so this entire thing, and the c over a, I'm going to give it another kind of variable here. So I'm going to call this just b. Let's call this b prime, because clearly I can't call it b because it's not the same thing. B prime x plus c prime. And now with this, the reason why I do that is because now it looks exactly like this, which is my original where a was equal to 1. And when it's in this form, when I have x squared plus bx plus c, then I know exactly what that c is. Now in this case, so as I scroll down, what I'm going to do is I'm going to try to find the perfect square out of this. So what is the perfect square? So what will this c right here be? Or what will it have to be? Well, that's not very difficult, because right here all I have is, remember, this b prime is given to me. So my c prime is going to be just my b prime divided by 2 squared, because that is coming from right here. And that was the link kind of to part number 1 that you were dealing with. And because I have this right here now, I can easily find what c actually should be. The reason for that is because don't forget that this c prime is just simply c over a, because that's what I called it, right? So I called this to be c prime. And therefore, so what I have is, so I have this entire thing, which is b prime over 2 squared. And now I can bring this a over to the opposite side, and it's going to give me that c is just simply equal to a multiplied by b prime over 2 squared. Now, don't feel like you're going to have to try to memorize these formulas, because with numbers, it's actually much easier to think about. You can always bring this a back at the end. So let me show you how to find these perfect squares on actually the examples that we had above. And then you can apply this as you like, because you're going to need it in future studies if you ever, for example, are trying to put the quadratics into the vertex form. So let's take this first example that we had right here. Let's actually take all of them. So I'm going to copy this entire thing. Let's bring it back down here so that we have it. And then we can break these down. Now our first example, which is the 2x squared plus 12x. And if I take that, what I'm going to do is, first thing, because my a is not equal to 1, I'm going to factor it out. And that's going to give me, so if I factor this out, this is going to be 2. All right, so we have now x squared right here, plus, I'm going to factor out the 2, which is going to be 6x, plus I'm trying to find whatever this new c prime will be. That's what I'm trying to look for. Okay, so that's the first step. So factor out your a. Now the next step is, in order to find this c, well, this c just comes from the b right here. So that's going to be b divided by 2, which is going to be 3. And it's 3 squared, which is going to be 9. And that's what this will be right here. So this comes from 6 over 2, which is equal to 3. And then that 3 I have to square, and that's going to give me a 9. So there is my 9 right there. So now I have now completed, I have my perfect square here. And if I want to bring this entire thing back to its original, meaning if I want to find out what this C, this original C is, then I can distribute in, okay, this 2 across this entire thing and get exactly, so this would have been 2x squared plus 12x plus 18, and this is your original C that you were looking for. And that is it. That's kind of how you would find your C. So it's not very much different than when the A is just equal to 1. The only difference is you're going to be factoring out your A. Let's try another example. So the second example right here that I have, let's break it down and then see how we can come up with our answer. So step 1, we're going to factor out the A. We're going to take this thing out so that I'm only dealing with something I'm familiar with. Notice it's negative in here, so this is the 3 has been factored out, so that's going to be 8x plus, okay, so my new C prime right here that I'm going to try to find. But that C prime is going to come from, again, so here's my B. So that's my B, which is 8 divided by 2, which is going to be 4, and then 4 squared, which is going to be 16. So I'm going to put this as now 16. And distributing across this 3, okay, so if I'm going to bring this back right there, then I'm going to get exactly what that question mark is. And the question mark is going to be simply 3, which is your A, multiplied by 16. And notice that's exactly what this formula was saying. So you have your B in the factored form, divided by 2, you square it, and then if you like, you can bring back the A to get your question mark right there. That's what you would have for that. The last example, because I want to show you now, in school, most of the time when you're starting, these numbers actually kind of nicely work out as they have for us right here. And that's fine, because they're just trying to teach you the actual concept. But as I often say, this is not typically the case in real life if you're working with things, because the numbers are not always very nice. So for instance, you can't even make them uglier. You can make decimals and you can make fractions. But I'll just give you one more example here where my A is equal to 5. And then when I factor things out, it's not going to look very pretty. And if I do this, so if I take my 5 out here, then I'm going to get x squared. Now here, factoring this out, this is going to be 18, okay, over 5x plus, and then I'm going to have now whatever it is that I'm trying to find here. And notice the factored out 5, well, 5 is not a factor of 18, so we have to put 18 over 5. And that's what makes this now a little bit uglier than the previous questions, but it doesn't change how we still find our C. So how we find it is, well, we take this, what I just highlighted in orange, and we're going to divide it by 2, which is 18, okay, 18 over 5 divided by 2. And if you divide that by 2, actually it's going to be then 18 over 10. That's what you will have. So that's going to be 18 over 10, okay, if we're going to be dividing this by 2. And that, I mean, in factored, in reduced form, because it's just a fraction, you can keep it as a decimal if you like as well, which is going to be 1.8. This is 1.8 as a decimal if you want to keep it, or you can also keep it just as a fraction, which is 9 over 5. That's divided by 2, but we have to square that, right? So if we're going to be squaring it, it's going to be 1.8 squared or 9 over 5 squared. Doesn't matter. And then finally, if you want to know what the original question mark or the original C is, you would have to bring in the 5 back. All right. So now if I bring in the 5 back, then what I'm going to get is I'm going to get 5x squared plus, this is going to be going back to 18x plus, and now this last thing is going to be 5, sorry, not 3, it's 5, multiplied by, and now you have multiplying it by the 1.8 squared. And that's what would have been your final answer for this one. All right, and then so whatever this might be, I mean, you can take out your calculator if you like. 1.8, and this is squared, it equals, so it's 16.2, or you can keep it as a fraction. That's how you actually approach these types of questions, and whenever the a is not equal to 1. All right, so you're going to be needing these as you're kind of completing your perfect squares. I hope that this was useful. We'll see you in a future video. Okay, bye everybody.